Next chapter, bearing and surveying. When you want to give the position of one place from another, say from A to B, you need two things: direction and distance. If, for example, you tell someone that from A to B is 25 kilometers, the next question will be towards what direction? If you just say 25 kilometers, then B will lie anywhere within a radius of 25 kilometers from A. The direction of a place with reference to another is given using bearing. The magnetic compass is used to indicate bearings in terms of the angle turned from another given point. So if you say B is 25 kilometers northwest of A, then your friend can easily locate B. We talk about direction in terms of 4 points: north, east, south, and west. We call this the 4 cardinal points. We can give more accurate directions by talking about these spaces between the 4 cardinal points: northeast, southeast, southwest, and northwest. We can even go further and give a 16-point compass direction and talk about these points: north-northeast, east-northeast, east-southeast, south-southeast, and so on and so on. This is a very useful way of designating 16 different direction points. But the problem arises when we talk about directions in between these points. Do we talk about south-southeast, southeast, or west-west, north-west, north? We end up with huge letters and still might not be able to locate all points. So instead, we use a different system. We use bearings, and bearings are set within a circle 360 degrees. The circle begins at north, and so north is 0 degrees. East is 90 degrees, south is 180 degrees, and west is 270 degrees. Finally, we return 360 degrees at north again. Equally, all the points between the cardinal points have their angles: 45 degrees, 135 degrees, 225, and 315. And the same for all directions in the 16-point compass. This allows us to be more accurate about a given direction. Let's take an example. 2 points, A and B, and the question is, what is the bearing of B from A? This means we are leaving A going towards B. It's very important that you know the direction of movement. So we place our compass at A, and you will see that this angle is 60 degrees. Now there are 2 types of bearings: true bearing and compass bearing. We start with true bearing. This is the most common bearing. For true bearing, we have to remember 3 things. First, the angles are measured from the north only. Secondly, they are measured in a clockwise direction. And thirdly, they are written with 3 figures. If there are 2 numbers, we add a 0 in front. North is equal to 000 degrees. East is 090 degrees. South is 180 degrees. And west is 270 degrees. So if we turn 60 degrees from north, that bearing will be 060 degrees. If we turn this much, let's see the angle. It's 40 degrees, and so the true bearing will be 040 degrees. How about this? It looks like 152 degrees. This one will be 250 degrees. And finally, remember you can't measure it in an anti-clockwise direction. So that will be 317 degrees. Let's take an example. We have these 3 points. The first question is the bearing of Y from Z. So we are coming from Z towards Y. We place the compass and we have 310 degrees. Y from X, we are leaving X and going towards Y. We place the compass, it's 45 degrees, and so the bearing is 045 degrees. Finally, Z from X, we are leaving X traveling towards Z. That is 115 degrees. Now compass bearing. Compass bearing are all directions given in terms of turning a given number of degrees east or west of north or south, whichever is closer to the position. It uses a combination of letters and numbers, and the order is north or south, the angle, then east or west. Let's look at this bearing of A. If you want to give the compass bearing of A, the first thing to think is it towards the north or south? Or is it closer to north or south? And the answer is north. So you write north. Next is the angle. How many degrees from north? It's 36 degrees. So you write 36 degrees. Finally, from north, is it towards the east or west? It's east, and so you write east. So the compass bearing of A is north 36 degrees east, meaning from north we turn 36 degrees towards east. How about this B? If you think about true bearing, we'd say that it's 135 degrees. But in compass bearing, it's different. We measure angles from north or south. The point B is towards the south. So we write south. From south, we turn 45 degrees. So we have 45 degrees. We turned towards east. So we have our compass bearing as south 45 degrees east. Now, given these 2 points, let's express them in terms of the compass and true bearing. For the first one, point B is southwards. The angle from south is 58 degrees, and that is towards east. So that is south 58 degrees east. How about the true bearing? We know from north to south is 180 degrees. We measure angles from north in true bearing. So from north to B, the angle will be 180 minus 58, and that gives us 122 degrees. That's the true bearing. The second one is a bit tricky. That angle 13 degrees is measured from west. But remember, in compass bearing, angles must be measured from either north or south. B is towards north. We know the angle between north and west is 90 degrees. If we move from north, B will be at 90 minus 13, which is 77 degrees. And that is towards the west. So the compass bearing is north 77 degrees west. How about the true bearing? We measure the angle from north and in a clockwise direction. You can work this out in 2 ways. The first one, north to east, then to south, then to west will give us 270 degrees. Then we add the 13 degrees. That gives us 283 degrees. The second method, if the compass angle here is 77 degrees and the complete turn is 360 degrees, then we can subtract 360 minus 77, which will give us the same answer, 283 degrees. Let's take an example. A ship travels from port A to B 60 kilometers away on a bearing of 035 degrees. Draw a diagram showing this information. So this is point A. We draw the bearing here, 35 degrees from north, and it will travel 60 kilometers. This is B. Now, if the ship returns to port A along the same path, determine the bearing of A from B. So this is the path back from B. The distance is the same. So we draw a compass at B. Then remember to measure the angle from north. So all this angle here. This angle is 180 degrees. Then there is an additional angle here which we don't know yet. But if you place a compass at A, you will reckon that these two angles are alternate and thus they are equal. And so Y is equal to 35 degrees as well. And so the total angle is 180 plus 35, which gives us 215 degrees. One more example. Our ship leaves port A and travels to B 65 kilometers away on a bearing of 115 degrees. It then sails from B to C on a bearing of 035 degrees. If the distance AC is 95 kilometers, draw and label the diagram. So we start at point A and we draw a compass. B is 115 degrees. That is the direction. If you want, you can say that this is 90, and to get to 115, we need another 25 degrees. And now we shall move from B to C. So we have a compass at B. 35 degrees is in this direction. We don't know exactly where C is on that line, but we know from A to C is 95 kilometers. So we measure 95 kilometers, of course using scale, and see where it meets the line from B. This is C. Now calculate the angle ABC. This is the angle. We already have 35 degrees, and so we are remaining with this one here. We call it X. Let me have these lines. Because all north-south lines are parallel, it means line AB is a transversal, and angle X is alternate to this angle here, which means they are equal. So if the whole of this is 180 degrees, and we already have 115 degrees, then 115 plus X is 180, and so X is 65 degrees, which means angle ABC is equal to 65 plus 35, which is 100 degrees. Now, the ship leaves port C and travels to port D, due west of port C and due north of A. Show port D on the diagram. So we have our compass back at point C. D is due west of C, so along this line, and then north of A, so this is D. Next, we look at surveying. Now, surveying involves measuring and recording of distances of points in an area. The measurements are then used to make a map, which is a scale drawing of the actual land, showing all the boundaries of the piece of land. We can use the map to then calculate the area of the land. Let's look at an example. This is a notebook entry for measurements of a piece of land, and we want to sketch the piece of land. The first point is to mark A, and this length here. We draw a straight line all the way to the point D. This is called the baseline. All distances on this notebook are measured from A. Starting from A, that is the 0 mark, we move 10 meters up to here. That's 10 meters we have traveled. At this point, there is a point B, which is 22 meters to the left. So we draw a line to the left, 22 meters, that is point B. Now we move 24 meters, again from A, and that is equal to 14 meters from the junction. At this 24-meter mark, we have a point E, 30 meters to the right. So 30 meters, this is E. Again from A, we move 40 meters. This is 16 meters from the 24-meter mark. At the 40-meter mark, to the left is a point C, 24 meters away. Then finally, we get to the point D, which is 55 meters from A, and that is equal to 15 meters from the 40-meter mark. And now we just join the points to complete the map. Another example. In this case, we will need to complete the field book entry. We have a sketch and we are working backwards now. This line here is the baseline, from P to R. These are the junction points. P is the point at 0. From 0, we move up 18 meters. From these 18 meters, we go another 10 meters. We will have 28-meter mark. 28 plus another 24 meters gives us 52-meter mark. And then 52 plus 20 finally takes us to 72 meters at R. So we have 18, 28, 52, and 72. So we mark that in our field book entry. So here at 18, we write 20T. After 28-meter mark, we have a point Q 26 meters to the left. So in the field book, we have Q 26. Next point is at the 52-meter mark. 18 meters to the right, we have point S. So in the book, 52, we have 18S. And finally, point R at the 72-meter mark. That's it. And now with this map, we can find the area of the piece of land. Let's have these figures as A, B, C, D, and E. A is a triangle. Its area will be given by a half times 18 times 20, and that gives us 180 meters squared. B is a trapezium. Its area will be given by a half times 18 plus 20 times 34, and that gives us 646 meters squared. C is a triangle. Its area is a half times 18 times 20, which is 180 meters squared. D is also a triangle. Its area will be a half times 28 times 26. That gives us 364 meters squared. And finally, E is also a triangle. Its area is a half times 26 times 44, giving us 572 meters squared. We add all of them and we get 1,942 meters squared.
You can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university. If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences.